Now, so this is all fine. Okay, it is, all these network of smart objects doing such fantastic things. Okay. But what are really the challenges and issues? And there are a lot of challenges ahead for such kind of Internet of Things, okay, whether in a small scale or in a large scale. Security, safety, and privacy. So these are the big challenges in front of us. Now, when you connect all these billions of devices to Internet, then you basically provide billions of entry points for malicious attacks. There are so many ways you can hack into the system. And once you hack into the system, you can do a lot of things depending on what is available with you. Okay, to you. Imagine if the hackers, just an example, they take charge of smart grid, okay, and so through the smart meter, for example, they access the utility system, and from there they access, say, all the smart meters in that area which are connected to their system. What can happen? They can switch off the power. Okay, so today smart meters have a capability of remote disconnect and remote connect. But typically it is used, to disconnect power remotely. For example, if you don't pay the bill, then they want to disconnect remotely. So want to avoid a visit. Or for example, if you move out of home and you give them a call, they will disconnect the power. So this capability is already there. Now, if hackers have the access to this system, then they can cause a lot of damage. Okay, and there's also one capability in the smart meters, which is remote firmware upgrade. Okay, so now you can also upgrade the firmware, and you can install the malware, for example, in millions of meters which are connected in that particular city to the utility system. So what may happen? I mean, if you want to, for example, take corrective action, and depending on situation, the only option left will be go door to door and change the firmware, because the firmware which is installed, the malware which is installed in the smart meter may not allow any more firmware upgrade. So the only way to change the firmware will be to visit and change the firmware. So which is massive headache for the utilities, and this can happen. And the researchers have demonstrated that such kind of things are feasible, is possible. Okay. Other implications, I take the same example of smart grid or smart meters, and another implication is privacy. Okay. Now, if I have access to your smart meter data, then I can infer a lot of things about you. Okay. So I can find out, for example, when do you switch on your TV? When do you switch off the TV? So there are a specific signature. Okay, when you switch on the TV and switch off. I can find out when do you switch on your washing machine. I can find out when do you leave home. Okay, or when I know everybody, all occupants leave the home, and when do they come back? I can have the inference, for example, do you get up at night? Okay, go to bathroom and switch on light. So many things I can find out if I have access to your meter data. And this meter data is sent to the utility every 15 minutes. So with that kind of granularity, you can do a lot of things. Okay. So this has implications basically. Okay. So if you hack into the systems, smart objects, then it can cause a lot of damage basically, and also safety. Okay. Many of you might have read about Stuxnet kind of attack, where Siemens SCADA system was compromised. Okay, and so the specific product from specific company was compromised. They came to know about the vulnerability or weakness, and now this is the industrial SCADA, which is used to control power plants or, for example, wastewater or water, for example, treatment plant, those kind of things. Now, when you compromise such SCADA systems, so The function of SCADA system is to keep an eye on all the sensors and all the systems, okay, safety systems and all these things, and take corrective actions. So if there is a problem reported, then SCADA systems will initiate the action. Now, when you compromise a system, it has implications. Okay? It has implications on safety. Say the safety of the personnel working in the plant, or even the safety of the end consumer, for example. Okay? So when you have the world where, in the world where billions of such systems are connected, okay, whether at your home or your offices or your factories, power plants, nuclear plants, your highways, intelligent highway systems and all these things, then it can pose a real challenge in terms of security and safety. You need to understand that compared to corporate IT, ensuring security and safety of this kind of internet of smart objects will be very difficult and very different. Okay, in a corporate IT world, you can immediately release the patch. It is homogeneous network, okay, and you can take action immediately. While here, it is a network of networks, and you have the products from the different vendors, okay, across the geography, and there are systems. We talked about wireless sensors, okay. We talked about the sensors which are deployed, okay, in large numbers in the field. Now, how are you going to apply the patch? If there is a problem with such systems, or take a transmission network, okay, electricity network, it is spread across geography. Okay, so how do you apply the patches and how do you ensure? Okay. So these are the big challenges, and the experts or the researchers are grappling with these issues. Another problem will be availability. Okay, another challenge, because the denial of service kind of attacks can disable part of the system or whole system. We just talked about the smart meter. They can basically cause a blackout in that locality. We talked about the confidentiality of data. If I access your data, then I know a lot about you. Okay, and also the data integrity. I mean, if I have access to the data, and I know how the data works, your data communication protocol works, then I can send the wrong data also, okay, and I can cause a lot of issue. So these are the main concerns today we have when you have so many such objects connected to the internet. So I'll go to the next slide. So these are a few more challenges what we have. So these are mostly like technical challenges, I can say. Now, although the standards have been developed and new ones are being developed as we speak, interoperability is still an issue. Okay, we talked about smart grid. Okay, smart grid alone, okay, it is just one application. It is just one industry. There are more than 70 potential standards that have been identified by the standards that we call the NIST list. Okay, we are just talking about just one application, one use case. Inside the building, for example, building automation. If you take, we talked about smart building. There are different standards. Okay, we have standards like BACnet, lawn works. There are so many standards. Okay, and all these standards are competing with each other, basically, and each proclaims that that is the standard, okay, to use. So we still don't know which standards will emerge victorious and which are the standards. So today, for example, if you want to adopt the standard, you don't know whether that standard will prevail. There is no guarantee. So you are basically taking a chance when you adopt a standard. Now, next is the cost. Now, although the cost is dropping, okay, it still needs to drop even more. Say applications like wireless sensors. Okay, if you want to deploy wireless sensors, in huge numbers, then the cost has to be negligible. It should be very less. Okay. You also need a better decision support system. Okay, more intuitive. more intuitive, more visual, so that the human operators, okay, who are taking decisions, who are making sense of this huge amount of data that is generated by all these devices and it is coming towards central applications. Okay, to make sense of this data, we will need a more sophisticated kind of applications. And data mining and reporting is still a challenge. Now, we are talking about the network. We are talking about the internet. Okay, obviously, and we are talking about devices which will communicate with each other, will influence each other, will coordinate with each other, and will take collective decisions to accomplish a goal. Now, all this is possible only if we have the network which is solid network, reliable. Okay, so that is the foundation, basically, for this IoT. So the reliability of the network, performance of the network, these are the key issues, especially when we are entrusting all these devices to coordinate their activities with each other. These are a few more challenges. Now, although energy management is improved a lot from what it was, you still need objects that will operate in the field for long duration without big power. For example, wireless sensors again. The wireless sensors, one of the benefits of wireless sensors, just because they are wireless, one of the benefits is you can locate them, you can place them where otherwise you cannot place. Maybe in a hostile or very hot environment or very cold environment, for example, okay, where you may not be able to use wires or cables. Or in a factory, for example, in industrial application, there may be a lot of vibrations, there will be a lot of noise, the electromagnetic kind of interference. There may be heat. Okay, so it may not be easy to lay down the cable. So wireless sensors have the attraction there. Okay, but now when you place these wireless sensors, wherever you want to place, then what about power? So they are mostly maybe, for example, battery power. Okay, changing batteries may or may not be easy. Now, if you deploy a lot of wireless sensors, for example, smart dust, across the field, okay, in the water bodies or battlefields, for example, or forest, for example, changing batteries is not an option, okay, for these kind of sensors. So that's where those kind of sensors or those kind of products will have to think about schemes like energy harvesting or energy scavenging, and they will have to employ those strategies. An example of energy harvesting is, if, for example, if you want to put a sensor on a machine, now you can design that sensor which will derive the power out of vibration. Okay, so you don't need a battery or you don't need grid power. You can generate the power using what is available. Okay, or same thing, for example, solar energy. So you drop the sensors on the ground. They can use solar, for example, and you need to design these sensors very optimally. They need to be very efficient, power efficient. So most of the time, these sensors will be sleeping, and they will communicate only when they have something to say, because the RF is still going to use a lot of power, okay, compared to the embedded microcontroller. RF is going to be constant for the power. Okay. Next is packaging and integration. Okay. So we are talking about the sensors and actuators which goes into the different objects, different machines, maybe in the material also. Okay, they may be part of some material also. Okay, so you can embed them in those materials. But there will be challenges. So for example, if we are talking about extreme environmental conditions. Now we took example of aircraft frame. Okay, now the aircraft frame, you want to detect the wear and tear or damage of the aircraft frame. Okay, now it's not going to be easy. Okay, to place the sensors wherever you want to place, because the 30,000 feet, the temperature is very, very low. Okay, sub-zero. Okay, and so there is a problem. Okay, whether electronics or batteries will work or not. Also near the engine, the temperature is going to be extremely hot. So how do you package those sensors and actuators where they can withstand that kind of extreme environment and still function? That is going to be a challenge. Okay. So that is back and tell you one more thing. So another challenge which you can see definitely. Now, we are talking about sensors, okay, and sensors and actuators, right? You know that sensors measure physical phenomena in real life. Now, the accuracy of these measurements it depends upon how well it is calibrated. Okay. So, okay. So, if it is well calibrated and it is up to date, then whatever it measures is going to be accurate. Or at least you should know the offset. Okay. So I'm off by so many degrees. So you take that into account when you take my measurement. So you need to know that. Otherwise, you cannot trust. So how are you going to calibrate these sensors, which are deployed in large numbers, okay, distributed, okay, maybe in very hostile conditions or inconvenient conditions, etc. So the deployment, calibration, testing of these sensors and actuators is going to be a challenge in many environments. And this problem needs to be addressed to realize the ultimate goal of IoT. There will be some policy changes also. Okay. So for example, these legal liabilities. So what happens now? We are talking about very smart objects which can apply the brakes, stop your car. We're talking about robots which can do a lot of things, and we're talking about industrial applications where the machines they take decisions, okay, vital decisions. So if something goes wrong, then who is to be blamed, okay, and who takes the responsibility? So we need to have the framework, policy framework needs to be designed. Okay, and companies, insurers, and governments need to work together. Also, we talked about security and the privacy issues. So, for example, if the utility installs smart meter into my home, somebody hacks into it and they get all the data about me, or they cause some damage, for example, place some mischief in my home, then who is responsible? Can I hold my utility responsible if for the damage that is caused? Okay. Do we need a strong regulations to mandate security testing, thorough security testing, right from the design stage, okay, where security becomes an important aspect of product development. Okay. It is going to be costly because it has a cost. You want to do that kind of rigorous testing, reviews, etc. Okay. But that may be required. If you want to generate the trust. Today, a lot of consumers have and end users have a lot of concerns about all these devices getting connected to each other and going on internet. Okay. Do we understand really the problems? Do we understand all implications of all these devices getting connected, okay, to the internet? Because if things go wrong, they can cause a lot of damage, and if the bad people get access to the vital infrastructure, okay, it can cause really a lot of damage. Waste management is going to be a challenge. So all these sensors and actuators, you are deployed, you have thrown it all over, like a smart dust and those things. What about the waste? Okay, when they stop working, what happens to them? Okay. Are they degradable, biodegradable, or we are just creating a lot of waste, okay, spread across? Okay, so that also is going to be a challenge, because once the technologies are available, the companies and the people will make use of it. So you will see a huge number of such sensors and such devices getting deployed, which you don't see today. Just because technology is available and you can derive the benefit, those technologies will be developed. So there is a challenge of waste management also. We may need policies for that also. Okay, so I come to the end.